Hello everyone and welcome to this video. In this video we're going to be talking through what you should expect in the Practical Data Challenge as a job application process for data science, data analytics and computer science roles. Nearly every data analytics job application will include some form of practical work to make sure that they can understand what your capabilities are and how well you can communicate. In this video, we'll go through what they consist of, what you should know, how to practice for them, and how to succeed as best as you can. So let's start with the basics. A practical data challenge is a scenario-based assessment that essentially simulates the kind of work you do in the role that you are applying for. You should think of it like a mini project, similar to what you may get in university. They give you a data set, a question or a goal, and they ask you to work through your approach. It's typically part of the second or third stage in the hiring process, once you've passed the initial screening by a recruiter. The goal isn't just to test whether you can code, even though that's an important part of it. It's to understand how you think, how you prioritize, and how clearly you can explain your results. It's one of the clearest ways for an employer to see your capabilities in action. And make no mistake, this is where many candidates are separated, where the good are separated from the bad, and where the prepared are shown and the unprepared are highlighted. It's more than just about technical knowledge, it's about your confidence and capability to communicate in a role similar to what you're applying for. It's about decision making and clarity under the constraints that you are given. Now the format varies by company, but they all aim to simulate work conditions. You might receive a take-home project with 48 hours to clean, analyze and model and explain your insights on. Others might give you a time platform challenge, something you have to do in real time during the interview. A bit closer to a coding test. These are much more common in technical roles such as software engineering and data engineering, and have a higher focus on logic and data manipulation. If you've done some practice on LeetCode or some coding challenges or competitive coding during your time as a student, you'll be very familiar with these type of challenges that you may face. Startups tend to favor short, high-pressure challenges to test speed and agility. Corporate teams often go for longer take-home formats that simulate a real work week. Regardless of format, they're measuring more than just accuracy. They want to know, do you ask the right questions? Can you make progress without perfect data? Do you interpret results through a business lens? And importantly, how do you communicate your decisions to non-technical people? Unlike education in university, the dataset you receive will be unprepared. It may be messy, it may be real, it may be purely synthetic off one of their real datasets. You will have to do a lot more than you are used to make that data usable and presentable. So, educational institutions are testing and employers are testing how well you can make the transformation from the work you'd be set at university to real life work processes. Most challenges follow a similar arc. First, you'll start with some exploratory data analysis. What's missing? What's noisy? What patterns stand out? These are questions you should be asking yourself. This is your chance to show curiosity and attention to detail. If you know the context of the business, if you're very keen about business analytics and you know the industry well, this is your chance to prove it by asking the right questions and really exploring the domain that you have been assigned. After the EDA, we'll go on to modeling. Maybe it's a classification task, maybe you're asked to do some forecasting, but here's the secret. You're not being judged just on model accuracy, you're being judged on your process. Why did you pick that model? How did you tune it? Did you validate your assumptions? Can you prove that it is your own work and your own design? It needs to match up to your curiosity, your domain knowledge, and your skills on your CV. Finally, communication, and this is so important and differentiates so many candidates. This is where most candidates stumble. You may be asked to write a short report, present your findings, or simulate stakeholder feedback. This part matters so deeply because if you can't translate your analysis into clear action, it doesn't matter how sophisticated your model was. So what separates a good submission from a great one? It's not one who uses the fanciest tools, it's who shows clarity, relevance, and purpose. Great submissions tell a story from start to finish. They start with a clear objective, then methodically walk through the steps with logical reasoning. Code is clean, commented, and easy to follow, even in a vacuum. Visuals aren't there just to impress, they should support your decisions and highlight insights. And here's the kicker, they explain trade-offs. Great candidates will say, I chose logistic regression over a more complex model because of interpretability was important here. This shows maturity, this shows business understanding and how workplace processes work. And finally, they bring it home to make a business impact. What's the recommendation from your data and your analysis? Who would care? Who is the target audience? What's the target demographic affected? And what's the next step the business should take to make your insights actionable? These are all so important and things you need to think about. Don't be too one-dimensional. Don't think too short-term. Be ambitious and communicate ambitiously. You want to sell yourself and sell your impact to the firm you are presenting to. Now, let's talk about landmines, mistakes that can really hurt your chances, even if your technical skills are solid. First, you need to understand the modeling, so understand the data and the context of what you are looking at. Before jumping into modeling the data, you need to make sure that you're designing a solution knowing the problem that you are facing. If you don't understand the problem or the domain or industry, you won't understand why the model is generating the data that it does and why data is leading to certain insights. Generating insights is one thing, anyone can do that, but understanding what the insights mean in the context of the business is another thing, and that's where you will set yourself apart from other candidates. Secondly, you're not just providing a narrative. A list of charts, code cells isn't enough. You need to guide your viewer and your audience through your thinking, through how your insights matter and what sets your presentation apart from other candidates. And thirdly, visuals with no explanations. This is very similar to the last point. If you drop a really nice heat map or a really nice chart into your presentation, ask yourself, have you explained what it means? Have you proven that you have enough understanding of your own results and your own output to present to a non-technical audience? We cannot just assume that the people watching our presentation will immediately grasp what information is being conveyed by the charts that you generate and the charts that you make. You need to essentially slightly spoon feed your audience into making sure they understand what the key points of your presentation are. And finally, don't forget reproducibility. If they can't run your code, you've lost credibility. Always test your submission from scratch and make sure that it is reproducible. A lot of the time, technical tests won't ask for your code, especially if it's a take-home test. But if they do, if it's a real-time test and you have to show your coding process, make sure you understand your code very well and don't be too ambitious if it means you're not entirely sure what your code means. And finally, how do you prepare and how do you stand out? So how do you get ready for this? First, practice end to end. Maybe pick a synthetic dataset on Kaggle or an Opal dataset from an open data portal and give yourself a time limit. Simulate the full process, exploratory data analysis, modeling, and even the write-up. Then ask yourself, could you present this to a manager? Secondly, build a portfolio. During the presentation, you are selling yourself as a person, and it's so much easier to sell yourself if you have somewhere where you've put all of your achievement and your accomplishments. beyond a CV. Hosting your work on GitHub or writing short case studies on Medium or LinkedIn helps you hugely before an interview and makes you really stand out. It also shows your passion for your work, which is incredibly important for continuous development. And thirdly, learn from others, like you're doing watching this video right now. Read winning solutions on Kaggle. Check out well-documented notebooks. If you're unsure about your technical skills in exploratory data analysis, go on DataCamp and learn a few courses on EDA. You get free DataCamp access with the IOA subscription. See how others are structuring their thinking and see how business analysts like to think in the real world. There is no limit to learning from others, and it will always be helpful no matter what journey and what stage on your career you are. And finally, remember, it's not about perfection. It's about clarity, relevance, and the ability to think like a data scientist and speak like a business partner. If you take all this into account, you should have a step ahead and a clear advantage over your competition. Good luck, and I hope you find that role that you are looking for.